Hi, my name is Arushi, and we are a team of three, Arushi, Prathi, and Preeti. We worked on Coda file system, that is efficient file sharing on Coda file system. So Coda file system originally was an improvement over AFS. So the main features of Coda file system is basically whole file caching, which means the whole file was brought from the server to the client and cached. And the other thing is disconnected operations. So now that the whole file is there on the client machine, I do not have to worry about being disconnected from the internet because everything is with me on my machine. So I can perform disconnected reads and writes. But when Coda was developed, we didn't care about large files. The files were very small in terms of KBs, in units of KBs or maximum MBs. But now the workloads are such that the files are really, really large. They're in terms of GBs. There are video files, map reduce operations. And when we try to fetch these big files onto the client, it takes a very, very long time. We are wasting a lot of network bandwidth. That is what we are trying to optimize over here. So what we are doing over here, what we changed is, instead of fetching the whole file from the server, we're going to fetch exactly what the user wants to read. And instead of writing the whole file back to the server, we're going to just write back what you changed. So this is what we changed in our architecture. This was the original Coda architecture. What we did earlier, this is the client and this is the server. So the client used to issue an open system call, which would reach the kernel. It will tell the cache to go and fetch the whole file, which reaches the server. It issues an RPC and gets back the whole file and caches it. And the user performs reads and writes, and then sends the whole file back to the server. What we changed in this is now, when the client says, I want to read a few bytes, he's going to tell the cache to go and get only those bytes. So say the user wants to read 0 to 100 bytes, he's going to tell the server, get me 0 to 100 bytes from that 10 GB file, and only 0 to 100 bytes would be gotten and cached over here and read. And say there is a very large 10 GB file, and the user just appended a period at the end of the file. Only that last 1 byte will be sent back to the server. So compare this with the original Coda where 10 GB was sent back to the server and we are sending only 1 byte back to the server. There is so much of network latency that we are saving. There's so much of bandwidth that we are saving. And that is what we want to achieve over here. So we did some performance analysis over here. So these are the two cases that we handled. One was a playback latency of file and the other is update propagation. This is in reads. So a user is not going to wait for a very, very long time for a video to start playing. So we are measuring how much time it really takes to start a video. This is the original Coda and this is our Coda. So we have a graph of file size versus how much time it takes. The original Coda would take proportionately long time to start watching a video, whereas our Coda will start playing the video as soon as the first chunk is fetched. So it's always constant time, and as the file size increases, original Coda will take like forever, and our Coda will take the same amount of constant time to start a video. And if you look at update propagation, what we did was we took a very large file and appended only a few 50 bytes at the end of the file and updated it to the server. So look at the difference. The original Coda, as the file size increased, would send back the whole file. So that is the network latency it's taking. Our Coda is going to just send back 50 bytes every single time. So it's always going to be constant time, and it's always going to be sending back only that much amount of data. Here is the optimization for Coda file system. We can show you a demo.
What we'll be showing you now is a simulation of two kinds of workloads. One of them is a video player, and what we intend to show is that in the original Coda, you wait till the entire video gets buffered, whereas in the new Coda, you play as and when it buffers. And the second workload is about asking only for a small portion of the file. In the original Coda, you would wait for the entire file to be fetched, whereas in the new one, you will display to the user as soon as you get the first kilobyte. So I will do the demo now. So what I'll do now is kill all the clients which are currently running. I'm going to initialize the old Coda. And I'm going to flush the cache just so that we get the file from the server. And I'm going to connect to the server again. So at this time, I'm going to run a workload which is essentially simulates a video player. And we see on the screen that we are fetching in chunks, and up until the time the entire file is fetched, you will not see anything on the screen here. And although and now probably in a little while you will find the workload returning saying that, oh, finally I have the entire file. But if I were to do it with the new Coda, it would not wait for the entire file to be fetched. So we are starting the new Coda and we are flushing the cache. We are going to connect to the server and then we run the same workload. But this time we see that it starts playing as and when it's buffering, although not the entire file is not fetched. So you can see only 27% of the file is fetched, and it will wait till, but it will still play until the entire file is fetched. Okay, so let's just wait till the workload stops. Okay. Now we are going to run another workload, which basically asks for a small portion of the file, and I'm going to initialize the old Coda to show the behavior and flush the cache and run that workload. It's called limited stream because it asks for a small portion. So you see that although I've asked for a kilobyte, it's not going to fetch the file, not going to display the file until the entire content is fetched. So you see there's nothing on the screen until the entire file is fetched. Now it comes back. But now let's run our new server and a new client, sorry. And I'm going to flush the cache and connect to the server and run the same workload, which is limited stream asking for a kilobyte. You see that it returns immediately after fetching the first kilobyte because that's all that the user asked for.